So in the previous videos, we derived a lot of theory for these first order linear difference equations and how they can help us with these rough models for personal finance. And in this video, what I want to do is introduce a few simple ideas and just have you play a little bit around with Matlab. So when we open Matlab, we've got, this is what it looks like on my machine. It should look like this with the way the windows are set up. And I'm speaking to you as if you've done no MATLAB at all. So if you're experienced with this sort of thing or with coding, then just bear with me. I'll get through this, and you can listen. You could listen to this video on 2 times speed and just blast through it and say you did it. Anyway, to those of you that this is brand new to, here's us in the command window. Now, in the command window is when I can type things like 3 plus 7, and okay, obviously 10. I push return, enter, and it tells me the answer is equal to 10. Thanks, that's correct. Now, it actually says answer is equal to 10. And over here in the workspace, and I'm going to make this a little bit bigger here. In the workspace, it's telling me that the variable answer has the value of 10 in it. So the variable answer always has like the last answer stored in it. And then I can use like answer minus 6, and obviously that's going to be 4, and it changes that to answer. Now, the answer value. But I can say a variable, let's say a variable a, I can make that equal to 3 minus 7, and now it's giving me this variable a, and inside variable a is stored minus 4. So if I say what's a again, it says minus 4, and now I can do math with that. So a plus 4 should be equal to 0. A is still minus 4, but now the answer is 0. So over here in the workspace, I can see what variable is what. That's going to be nice for debugging. Now, once I hit return, these double arrows here are saying that's the command line I'm at. I can't go back up here and hit return again. This is all stuff that's already been run. So right now I'm using this command window as like a glorified calculator. And I can do things like square root of 9, which is going to be 3, and it'll change answer to 3 up here. And I can do things like square root of a. Okay, now it's going to have a conniption because I'm asking it to take the square root of negative 4. Oh, it doesn't have a conniption. It just gives me the complex number. Nice. So then this square root command that I typed in here, square root, there's a lot of math that's happening in the background for that square root. That's where I want to go with this right now, is I want to make scripts that I can call. I want to make functions that I can call. So up here in the editor, I'm going to make a function. I've got one here called next value. Now what we're doing then, we're doing the first order linear here. So it's first order linear is our next value, our x sub n plus 1, the next x value is equal to take the last x value, the previous x value, multiply it by a and add b, and a and b are constants, and that gives you the next value. All right, so my function then has an input, and the input is this x value. So what does it do with it? It's the y value is going to be the output. It's going to take the x value that I input, multiply it by a and add b, and put that into y value, and y value is going to be the output like that. Now so here's what I want to show is the structure of this. Now, full disclaimer before we start, getting into this, I'm not putting myself out there as I am the best MATLAB coder ever, because that's totally not true. I'm showing you how I did this. There are other ways. There are more elegant ways. The way I show you is usually the way that's most clear to communicate, but it's not the most elegant way to do this, and it's not the way you would do this if you were a much more sophisticated, better programmer. But it's the easiest way to communicate how this is done. So I'm saying here this is a function. In the square value is the thing that comes out, the y, I'm calling it y value. And I'm naming it next value. It's a function of x. So there's only one input, you put an x in, there's only one output, it's that y value that comes out. The a and the b. So let's run this. Just like I ran the function square root. Square root has a script. I don't see it here, but it has a script that's all written and figures out, to give me the square root of 9 to be 3 and the square root of a negative number to start to go into complex numbers. It's a more complicated function that's written, but so I want to do this next value. So I named it next value. And now I'm going to input a number. Oh, notice here the help comes up. So there would be a help on the square root that I could hit. This is a function, this next value function is a function I made up. Matlab starts to make its own help with that as well. It's saying it's waiting for a value. The input is coming in. So I'm going to put 2 in. Okay, now next value 2. What's it supposed to do? It's supposed to take 0.7 times 2, okay, 1.4, and add 1. So the answer should be 1.4 when I run that. Or sorry, 2.4, duh. 1.4 plus 1, 2.4. So there it is. The answer is now 2.4. Oh, this a didn't change. This a is still minus 4, and yet I had in here a is equal to 0.7. That's because this a and this b are inside the function. So they're variables that don't come outside of the function, that don't have any meaning outside of the function. They're just inside. So I could change them if I wanted to have the function, instead of multiply by 0.7 and add 1, I wanted it to multiply by minus 0.7 and add 1. I could change that. Now I'm going to have to save that function. So now I've changed the a and changed the b. So if I go next value again times, that'll be next value 2, that'll be minus 1.4 plus 1. Now instead of retyping it, I'm just going to hit the up arrow and it tells me all the commands that I already typed in, and I'm just going to pick that next value 2. And if I hit return, it gives me minus 0.4. Again, it's not changing the a and the a value outside, and there is no b value outside if I look at the workspace. I could also do things like I'm going to say the variable name Bill. I'm going to make it equal to next value at 0. So it's going to plug 0 in my function, minus 0.7 times 0 plus 1. So next value will have an output of 1, and it's going to make that variable Bill equal to 1. And now it pops up here, Bill. Now I can use Bill on the outside as a variable. It's equal to 1. So I made a function. Now let's go back to here. Let's go back and look at the syntax of the function. Function, square value, that's going to be the output. This could be multiple outputs. So this could have, you could output a y, you could output a couple of different values. Like if I put a comma in here, I could output a y value and a z value, let's say. The next value is the name of the function that I use to call here. And x in the round parentheses, there's only one input. But that could be multiple inputs. Right now it's simple, it's just one input. Now these green lines here with the percent sign, when MATLAB sees a percent sign, it ignores everything afterwards, so that's a good place to put comments. Why would I put comments? I want to tell future me what this script does, what this little program does. And if I don't put that in, then then future me, when I call up the script, I'll have to refigure out exactly what it does. So commenting your code is a good idea. It helps you in the future. So it's telling you what this does. Now I've A and B value. Now let's take a look at, I'm going to remove some of the semicolons here. If I remove that semicolon, then when I do next value 2, without the semicolon, it runs this function. I told it to run this function with x equal to 2, and it did. But as it's running this function, it outputted this y value, and it typed it out. If I don't want to see it, then put the semicolon, and then I won't see it. It still calculates it, but I don't see it. Like if I do next value, in fact, I'm going to put bill equal to next value 7, but I'm going to put a semicolon. So bill has a value of 1 now. Now bill has a value of minus 3.9. So Matlab did run the script. It just didn't print anything. Some other things here that I can make this script a little bit better. Well, I could comment what A is. Percent sign after here, A is the number I multiply by. I could, but I think I have the formula here, and I know what a first order linear difference equation is. So maybe that's okay for, code that just I'm looking at, just I'm using. Something though that maybe could be made a little bit better. If I wanted to change the A and the B, like when we were doing here, our A was 1.05 was, the 0.05 was the interest rate. I would have to go in, and the 50 was like $50 at the end of each year putting in. I would have to go in here and change this, to 1.05 and this to $50 and then save it. But if someone said, oh no, the investment only makes 3%, I'd have to hard code in here in 3%. That's not good code writing if I have to keep changing it. So I've got a couple of ways that I could deal with this. I could make this A and the B variables that are outside the function. So I could say A is equal to 1.05 and B is equal to $50. And then okay, I don't want to erase that, but I don't want it to read. So I'm just going to throw some percent signs in front. So the lines are green. Oh, it doesn't know what A is because A is an outside variable. So what's inside the function is its own encapsulated object, we would say, but it doesn't know what the A is. So I need to read in the A as well. So I could read in the A and read in the B. And now I've given this 3 values. What's the A and what's the B? So if I type in next value 7, no, I have to tell it read in the A and read in the B. Now I didn't type in the numbers because we already sort of not hard-coded, we already in the outside workspace picked an A and a B. And now I had the semicolon there, so it didn't print it out, but I can see it changed the bill value to 57. Let's redo that, but without a semicolon. There. So now it's taking in 3 values. This is maybe a better function because I can use it. It's easy. It's better to use with other functions. It's more useful that way. So I could do, all right, no, it's not. If I know what the A and the B is, what about if it's 3% and $60? 67. All right, so this, now we know how to make a function. You can take this structure and change the inside here to do what you want. Whenever, if it doesn't work and you get an error and you need some help, you could go to the Matlab help up here. I would recommend before you do that you just Google how do I do this in Matlab, because you'll get a bunch of more useful help to start with than using the actual Matlab help. Anyway, next thing is the for loop that I wanted to show. So I want to clear all this space here. So that just clears the command window, CLC. So now I'm looking at a loop. So this is a for loop. What I want this to do is I want it to repeat something 100 times. So I made the loop number 100 times. So for the variable I from 1 to loop number. So the first time I is 1, then it's 2, then it's 3, then it's 4, then it's 5, all the way up to, well, 100 is too much. Let's just do 10. And whatever's inside here, so this for and this end is the end of the loop. So for I equal 1 hits the end, then 2 hits the end, then 3 hits the end. And then once you get to 10, it stops doing what it's doing. So whatever I put in here, it's going to do 10 times. What should we do? Well, let's use our next value. And I'll just, see the help popped up. So I'm going to make x equal to, the I, and I'm not going to change AA. I'm not going to change A. Let's make that 5%, and let's make the B the amount of money that we add each time. Let's make that 10 bucks. So the first time it runs through this loop, it's going to have $1 multiplied by 1.05 plus 10. Then it's going to have I is $2 multiplied by. Now, if I run this, okay, every time it runs, every time the loop is, okay, this df, I didn't need that there, so I'm going to get rid of that. Every time it runs, it reprints out this next value. And that's because I could put a semicolon here. Now when I run it, it ran it, but it didn't bother printing out all the values. And so, but then at the end, let's see, we got here loop number is 10. Yeah, I said that at the beginning. The last I is 10. The last I is 10. It was 1, 2, 3, 4, but it keeps updating it up there. And there is no, next value. It didn't do anything. It didn't output anything. But what I could do is I'm going to call output now. So output one is going to be with plugging 1 in, output 2, etc. And when I run it, now this output, this output here, output 1, output 2, output 3, this output is it's a 10 element vector with all those numbers in it. So it's saving it each time. And if I wanted to look at it, I'm just going to click it. It's going to open it up with a spreadsheet. Here are all the values. I'm going to go back to editor. Lastly, then, I'm going to plot it. plot this vector. There it is. It made a line that went through these values. And there's all these different ways we can make this plot look better, which I'll let you play around with. So lastly, before I go then, this loop, I mean, I could have just made this 1:10 and hard code that, but I think it's better to have the variables kind of outside like that. Anyway, what can you do now? Should be able to make a function, should be able to make a loop. You can put your function in a loop.